Hi students, today we are going to discuss the introduction about the cell. In the starting of the chapter we had discussed cell is a device which converts chemical energy into electrical energy. There are some types of cells which could convert the electrical energy into chemical energy back. So those are the types of cells we will be discussing later. So the first, battery, battery is the combination of these cells only. So today we are going to discuss about the introduction of the cell. What is this cell? How it will be converting chemical energy into electrical energy, and what are the terminology related to the cell. And you can see here, so we will be covering in this session about electric cell, EMF, what exactly the EMF we will be learning it, and internal resistance and terminal voltage, right? And few problems related to these concepts we will be doing now, right? So let us start. So electric cell, so I am writing here, electric cell is a device which could convert, it's a device which can convert chemical energy into electrical energy. I told you that there are some cells which can convert the electrical energy into chemical energy back, and what are the types of those cells, and let me write here. So this is electric cell are divided into two types. So the primary cell and the secondary cells. Commonly used cells are the secondary cells in our daily life purpose. So primary cells are used majorly for experimental purpose. In our daily life also there will be some primary cells. What are those? Let us discuss. And these are the primary cells will be used for single purpose. That means single use, one time use. You can call it as use and throw cells. So the examples of them will be Leclanche cell or Daniel cell or avalanche cell. So these are the cells you can see in your laboratories. So for example, take a cell, a simple pencil cell which will be keeping in TV remote or in your wall clock. So those are the single use. You cannot recharge them, right? So those are called primary cells, single use, throw and use, right? So now secondary cells. Secondary cells are two-way usability will be there, right? So what does it mean, two-way usability? So secondary cells can convert chemical energy into electrical energy, from electrical energy to chemical energy once again. That's called rechargeable. So I am writing here, so the secondary cells are rechargeable here. Secondary cells are rechargeable. So those are the cells we will be using in our mobile phones generally, right? So those are called NIFE accumulator, lead accumulators, right? Alkali accumulators. So those are secondary cells, right? So the major thing in the secondary cell is this one. Chemical energy will be converted into electrical energy, and again electrical energy into chemical energy. Imagine we have a lead accumulator in our mobile phone. That's what the battery or the cell is made of, right? In our mobile phone. Initially what happens? We will be using the mobile phone. So that means you are using electrical energy. From where that electrical energy is coming from? From the chemical energy of the battery or the cell. Okay. So completely used, it is used. So our mobile phone will be switched off because there is no chemical energy to convert into electrical energy now. So again we will be plugging the charger. Then what happens? So from the electricity, the electrical energy will be entering into the cell. So it will be converted into chemical energy and stored with this. So once we remove the charger, again the chemical energy will be converted into electrical energy. And this is where the two-way purpose will be there for the secondary cells. This is the small introduction about electric cell. And each electric cell is a driving force for the electrical energy, right, which maintains a constant potential difference. So I had told you already, cell or a battery will maintain a constant potential difference in a circuit, right? So that is what I am writing here. So this is the electric cell which maintains a constant potential difference in a circuit. So from where this constant potential difference will be maintained, how it is happening, all those things we will discuss in the concept called EMF, right? So what is EMF? You know, this is the interesting part. EMF is electromotive force. Electromotive force, right? So to understand the electromotive force, so you should recollect a small concept in your chemistry subject. And let's see, the cell looks like this. Inside, I'm talking about inside. Outside you cannot see all these things. So there is a small container here. So this is called electrolyte. I'm talking about the internal structure of the electric cell. There is an electrolyte here. Electrolyte is a chemical solution which will have cations and anions. Okay, cations and anions. Anions are the positively charged ions. Cations are negatively charged ions. Okay, so this is the electrolyte which will have positive ions and negative ions. Okay. Now, there will be two electrodes I am keeping here, right? Electrodes are the conducting rods. This is what the electrode. Now, when you keep an electrode here, so you know all the positive ions will be reaching to one electrode, negative ions will be reaching to another electrode, depends on their nature here and here. So this is what the electrode is called as anode, and this is the electrode is called as cathode here. So there is no connection between anode and cathode externally I have given. Okay, so but internally there is a connection because electrolyte is a chemical solution, right? Electrolyte is a chemical solution through which electric charges can flow. So that means this is the conductor, right? Electrolyte is a conducting material here. So there is a connection between this anode and cathode inside the cell, but outside the cell there is no connection I have given. Okay, now, so this is the anode will be having a high potential now, right? There is a potential for the anode and there is a potential for the cathode. And I am writing the potential of the anode is V plus its high potential because positive charges are accumulated here and the cathode will be at low potential. And you can see there is a constant potential difference maintained in a cell, inside the cell. That's called EMF, right? So there is no current is drawn from the cell. We have not connected this cell to any other conductor or any other electrical device or to any other resistance, right? I hope you are understanding. So this is just a cell which is not connected to any external resistance. Okay, so this is the constant potential difference maintained is called EMF, which is electromotive force, right? Electromotive force, right? So why the name is given as a force? Understand? So because this is the driving force for the charges to flow when the cell is connected to some external resistors, right? So now it is called electromotive force. So there is a constant potential difference is maintained within the cell, that's called EMF, right? So that constant potential difference, delta V, change in potential will be what? Potential difference V plus minus V minus, right? Now This is, I'm writing here, the constant potential difference maintained in the cell when there is no current is drawn from it. It is called EMF, right? So this is called EMF. When there is no current is drawn from it, you see, when you connect a conductor here or a resistor here, so there will be a current passing through that, because this is at high potential, this is at low potential, and the circuit will be completed. Here the circuit is not completed. So this is called the open circuit, right? So we will be describing or informing about the concept called EMF only during the open circuit case, right? So this is called electromotive force. Here, one more important point we should learn about EMF. And this is the electromotive force depend on only two things. So first one will be nature of electrodes, and the second one is nature of electrolyte. Okay, so nature of electrodes and nature of electrolytes, only on two things the EMF depends. Now, what we have discussed, the cations and anions will be moving towards cathode as well as anode, vice versa, through this electrolyte. Okay, when the charges are flowing through this electrolyte, and this electrolyte also will apply some amount of resistance to the current flows through the electrolyte, right? Again, I'm telling you, listen to me carefully. The electrolyte will apply some amount of resistance to the charges flowing through the electrolyte. That's called internal resistance. I'm writing here, listen to me carefully. So resistance offered by an electrolyte, the resistance offered by an electrolyte to the current flow through electrolyte. So this is called internal resistance. What is the internal resistance here? See, internal, as its name indicates, it is related to the internal concept. So denoted with the symbol small r. So you know the external resistance is denoted with the symbol capital R. So that is internal resistance. Okay. Now, so that indicates each cell will have some internal resistance. Okay. So cell having EMF and internal resistance can be represented in this way. You can see here. So this is what cell having EMF. EMF is denoted with the symbol E and having SI unit volt only. Okay. So EMF, what we have discussed here, the constant potential difference. Potential difference unit is what? Volt. So EMF symbol is E or epsilon and SI unit is volt. And this is what the internal resistance denoted with the symbol R here. Okay. So, and one more important point here. So this can also be represented in this way. So see here, E comma R. E is the cell having EMF E and R is internal resistance. Now, factors affecting the internal resistance. In some of the years, AIPMC exams, the question was asked based on internal resistance. That was a associated reasoning type question. So this internal resistance will be depending on four important factors, right? Number one, the internal resistance is depending on the distance between the two electrodes. This is one electrode, this is another electrode, so there is a distance between them. When the distance is more, internal resistance will be more. So that's the first thing. And the second thing will be the internal resistance is denoted or related with the concentration of the electrolyte. So if the electrolyte is high concentration, then the internal resistance will be more, and vice versa. And the same internal resistance is inversely proportional to temperature. So when the temperature of the electrolyte is less, internal resistance will be more. Okay. So now the same internal resistance is inversely proportional to area of the plates. So area of the electrolyte plates are more, internal resistance will be less. So here directly proportional relationship I had mentioned here, inversely proportional relationship I had mentioned here, right? So that's called internal resistance. So out of 4 important things, we have finished 3. Number 1, electric cell, EMF, internal resistance. Now the concept called terminal voltage, right? What is meant by the terminal voltage? We will be doing it now. Let's understand the concept called terminal voltage. And this is the terminal voltage is denoted with the symbol V, capital V. It is exactly similar to the concept called potential difference across the 2 ends of a resistor, or the potential difference across the 2 ends of a conductor, right? Same concept. So the potential difference across the 2 terminals of a resistor, that's called terminal voltage. Imagine this is the cell which will have EMF E and internal resistance R. For this cell, I am just connecting an external resistance. See, there is an internal resistance, external resistance I am connecting here. So that is here, you can see here. So this is the external resistance R is connected here. So now the circuit is completed. So I am writing here, now circuit is completed. So when the circuit is completed, the current flow starts from high potential to low potential. So this is the anode is at high potential, right? So current flow will be there through this and through this and through the electrolyte and through here, again reaching to the same point, right? So now this is how the circuit is completed here. So the potential difference across the 2 ends of this resistor is called terminal voltage. Okay. So now I am writing here. So the terminal voltage V is equal to I into R. Right. So this is the terminal voltage in terms of external resistance. So the same terminal voltage can be written in terms of internal resistance as well as in EMF. So what is that? How is that? Let's see. So the same circuit I am just redrawing. The same circuit I am redrawing. How? Look at here. So there is an external circuit, external resistance R is here, and which is connected to the cell, right? So this is the cell having EMF and internal resistance. Okay. Sometimes this may or may not be given. In that case, they will give this is EMF and this is R, right? So this is the external resistance. Now it's a positive terminal here, negative terminal is here. So then now the current is started flowing. So this is current started flowing. Okay. So the terminal voltage V is equal to IR between this. Understand? So now this is V is equal to IR. So let us write the same terminal voltage expression in terms of E and R. How? So we know according to Ohm's law, I is equal to V by R. V is the potential difference across the resistor, it's fine, but here R is the resistance which is the combination of external and internal, because there are 2 resistors here. So one is internal resistance, another one is external resistance. Okay, now so let me write here V. So what is this V? So sorry, actually this V is the potential of the cell or the battery, because for the complete circuit in Ohm's law I is equal to V by R, where V is the potential of the battery, right? The complete circuit potential. So here the complete circuit potential, which is the driving force, which is the source of energy, is this EMF, right? So that's E. divided by R. R is a combination of both internal and external resistance. So here what I can write, so epsilon E is equal to cross multiplication IR plus I small r, right? So this epsilon is equal to, what is this IR? So this IR is the potential difference across the resistor, that's called terminal voltage, right? So V plus IR. So now V is equal to E minus IR. Look at the interesting thing. So this is called the terminal voltage, and this is also called as a terminal voltage, right? So this is V is equal to IR, that is saying V is equal to epsilon minus IR. So in this case, two important things we need to understand. Two important things. The first one, outside the cell, when the external resistor is connected, how the current is flowing? Current is flowing from anode to cathode. Outside the cell, the current is flowing from, I am writing here, outside the cell, current I is from where to where? From anode to cathode, right? So within the cell, I am writing inside the cell. Inside the cell, how the current is flowing? So current is flowing from cathode to anode, that you have to understand. So I is from cathode to anode. Okay. So after, this is the first point. And the second point, the first one. And the second thing is the most important topic. While solving the numericals, it helps you a lot. So what is that? And let's see. So here, there is a cell having EMF and internal resistance. So there is another cell having EMF and internal resistance, right? So here, the current flow is given like this. It's a positive terminal and negative terminal, right? So the current is starting from positive terminal and it goes to the external resistance and comes back to the negative terminal. Okay, that's the aim of the current. Starting from positive terminal, reaching to the negative terminal. So this is called discharging, because current is drawn from the cell. So I am writing here, this is called current drawn from the cell. So that is the process called discharging. And while discharging, and what you can write, so your V is equal to E minus IR. This is the general concept. From a cell, we will be discharging. So that's called chemical energy is converted into electrical energy. V is equal to epsilon minus IR. V is equal to epsilon minus IR. That's called discharging. And I told you, in the secondary cells concept, we can give electrical energy to it such that it will be converted into chemical energy and stored with you. So that's a concept here. So we will be giving the charge. Understand? So we will be giving to this. Fine? Clear? So that's called current is given. That is called charging. Discharging case is different, charging case is different. That's called charging. And in this case, so your terminal voltage will be written as, so E plus IR. So this is for discharging and this is for charging. Okay. So this is how it goes. We will be giving it and we will be drawing from it. And let us solve the basic numerical, how the questions will be asked based on these basics. And we have not entered the actual concept of the cells. We are just discussing the introduction about the cell and the basics. So now let us see the example here. So there is an external resistance of 15 ohm is kept here, and there is a cell of EMF 10 volt and internal resistance 5 ohm is kept here. So the question is, this is the point A and this is the point B. The question is to find potential difference across the 2 points A, B. So that's called the terminal voltage. They are asking you to find out. So the terminal voltage. And how the terminal voltage you can find? So whichever is the easy way, you can find that. So either you can apply V is equal to IR. So because the current value if you know, you can do that. Or you can find V is equal to E minus IR. So to find both, you need the current in both the ways. Either you can find in this way or you can find in this way, because both are terminal voltages only. Okay. Here you need I because R is given external resistance. Here you need I because EMF is given and internal resistance is also given. So our aim is to find current. How to find the current here? So I have told you already, I is equal to V by R. So listen to me carefully. V by R. So V is epsilon because the source of energy, the source potential of the circuit is E by R. So where here, so what is E by R? R is what? Net resistance. This is for the complete circuit, right? So net resistance will be total resistance, external plus internal. So you can easily do it now. I is equal to epsilon, it's 10 by internal resistance and external resistance. Together it is 20. You can see 15 and 5 both are in series combination. Okay, same current will be flowing. It's a positive terminal, negative terminal. Same current will be flowing through it. Okay. Now, so how much it is? So it is just 0.5 ampere. So the current passing through the circuit, a current drawn from the cell, it's a charging or discharging? It's discharging. So when the current is drawn from the cell is 0.5, you can easily find the potential difference across AB. So let us start. So V is equal to IR. So I is 0.5, R is 15. So what is that? 7.5 volt. It's a potential difference across AB or terminal voltage. So in the other way, R, I told you can also use this one. Let's apply. So V is equal to your epsilon. What is your epsilon value? 10 or E minus IR. E is 10 minus I is 0.5 into R. What is your internal resistance? 5. Right? So what is this? 10 minus 0.5 into 5 is 2.5. So you can write V is equal to 7.5 volt. Understand? Clear? So this is the concept how to find the potential difference of the terminal voltage, and this is the terminal voltage concept. I hope you are understanding. Now we will be solving more numericals related to the basics. Let us solve few numericals related to the basics. A battery of EMF 10 volts and internal resistance 3 ohm is connected to a resistor if the current in the circuit is 0.5 ampere. What is the external resistance and terminal voltage when the circuit is closed? So obviously when the circuit is closed, then only the current flow takes place, right? So now let's start. So this is a simple diagram I'm just drawing here. So the EMF is given as 10 volts and internal resistance is 3 ohm, which is connected to an external resistance R. So they have clearly mentioned that the current of 0.5 ampere is flowing through that. What is the external resistance and the terminal voltage? So first external resistance let us find out, because to find the terminal voltage, so either you can use the formula V is equal to I into capital R or V is equal to E minus I into small r. Anything you can do that. So for that, first thing, internal external resistance, I just wanted to use this formula. External resistance we can find it. How? We have I is equal to E by capital R plus small r, right? So from here, I, it's 0.5 is equal to epsilon, it's 10 divided by capital R plus small r. Okay, so now this one, how I can write? So capital R plus small r is 3, which is equal to 10 divided by 0.5. Okay, now here, So capital R is equal to, so what I can write here, 0.5 into 20s. Okay, so 0.5 into 20s is 10. So this is 20 minus 3 will be 17 ohm is the external resistance. Right? So when it is 17 ohm, what is the potential difference across this? So V is equal to terminal voltage I am talking about. So terminal voltage V is equal to I into R. What is I? I is given as 0.5. 0.5 is 1 by 2 into R is, we have got it as 17. So how much it will be? It is 8.5 volt. That's the terminal voltage. So now you can check from yourself. So you use this formula, you can also get your answer. V is equal to same 8.5 volt, right? You check it. Epsilon is given 10 minus I is given 0.5 into R, internal resistance is given 3. You will get the same. Understand? Why? Because these are the two terminals. Between them we have found the potential difference. That's called the terminal voltage. The same two are the terminals across this battery also. Understand? So these are the two terminals across this resistor, as well as the same two terminals are across the battery. So that is called the terminal voltage. Right? Across the two terminals of the battery or across the two terminals of the resistor. So now let's start the second one. Given potential difference across the terminals of the battery is 10 volt. Terminal voltage is given 10 volt. Discharge. During discharge condition, I is equal to 3 ampere. So I am writing here. So during discharging, we have discussed what is discharging. So during discharging, so V is equal to E minus IR. What is V? So 10 is equal to E minus current is given as 3 into internal resistance R. So it's a first case, right? Now, in reverse condition is charging. In reverse condition, V is equal to E plus IR, right? So that's a charging condition. So current is 2 ampere and the terminal voltage is 15. So 15 is equal to epsilon minus 2R. It's equation number 2 here. So the question is to find internal resistance. Let's solve these two equations, right? So let us do equation 1 minus equation 2, right? Equation 1 minus, left hand side I am just subtracting. 10 minus 15 minus 5, which is equal to epsilon minus epsilon gone, minus 3R minus of minus plus 2R, right? So minus 3R minus of minus plus 2R. So what I can write here, sorry, it's a plus, right? Okay. Minus 3R minus of plus, it's minus 2R. So minus 5 is equal to minus 5R minus minus cancel and R is equal to 1 ohm. Yes, that's it. Understand? Clear? So this is the root. Now, a cell supplies a current of 2 ampere when it is connected to 5 ohm resistance. So there is a 5 ohm resistance when it is, there is a cell here. Cell, they have not mentioned anything about E and R, just the current supply is 2 ampere in this case. And it supplies a current of 1.2 ampere when it is connected to a resistance of 9 ohm. So there is 9 ohm resistance when the cell is connected. This is EMF E and R. It's connected, then 1.2 ampere current is flowing. So what is EMF and R? So simple here. I is equal to EMF is E by R. What is R? 5 plus smaller. So what is I? I here, it is 2 is equal to epsilon by 5 plus R. And here I is equal to E by capital R plus small r. That's 9 plus small r. So here I is 1.2 is equal to epsilon by 9 plus r. Okay. Now, so imagine it is equation 1, it's equation 2 here. Right? Now, what we have to do? So you just divide this equation 1 and 2, so you get the answer. Equation 1 by equation 2 if you do it. So here it's 2 by 1.2 which is equal to epsilon by 5 plus r into 9 plus r by epsilon. So epsilon cancel here. So what you can write now? It's 2 into 5 plus r which is equal to 1.2 into 9 plus r. Right? Now it's 0.6. It's 5 plus r is equal to 0.6 into 9. It's 5.4 plus 0.6 r. So from here, it's r minus 0.6 r. It's 0.4 r which is equal to 5.4 minus 5. So it is 0.4. See, r is equal to 0.1. So I am writing here. So capital R is equal to. So you got 1 ohm. So when this small r, you substitute any of this. So you get EMF also. So let us substitute here. Okay. So what is this? I is equal to epsilon. I is 2 here. So equation 1 you substitute. So 2 is equal to epsilon divided by 5 plus small r, it's 6. So from here, epsilon is equal to 12 volt. So 12 volt and internal resistance is 1 ohm. So like this, questions can be solved and they will be asking similar to this. These are the basic model of questions on the introduction of the cell concept. Right?